Hello everyone, welcome to my channel where we are learning DSA concept wise. So let's have a look at today's problem. Before jumping to today's problem, first can you let me know which algo you will use to solve these problems? The first problem is rotten oranges, where we have given a grid of dimension n by m, where each cell in the grid can have values 0, 1 or 2, which has the following meaning. Empty cell, cells have fresh oranges, cells have rotten oranges. We have to determine what is the earliest time after which all the oranges are rotten. And the second problem is prerequisite tasks, where we have given n tasks labeled from 0 to n minus 1. Some tasks may have prerequisites. For example, to do task 0, you have to first complete task 1. We have given total number of tasks n and a list of prerequisite pairs. So we need to find whether it is possible to finish all tasks or not. The next problem is alien dictionary, where we have given a sorted dictionary of an alien language having n words and k starting alphabets of standard dictionary. We need to find the order of characters in the alien language. Last but not the least problem is knight walk, where we have given a square chessboard, the initial position of knight and position of a target. We have to find the minimum steps a knight will take to reach the target position. So any algorithm is coming in your mind? Exactly. We can use breadth first search traversal of graph to solve all these problems. So now let's understand BFS, breadth first search. BFS is a graph-based traversal algorithm that helps to traverse the graph level-wise, similar to level order traversal of a tree. Now let's understand BFS in deep from this graph. Let's take 1 as the starting node. So first let's mark 1 as wasted because we are already at 1 and put it in our sequence of traversed nodes. From 1 we can move to 2 and 4. So first we will traverse to both 2 and 4 one by one. Then we will traverse further. So to keep the track of sequence of nodes, here we will use a queue and we'll insert 2 and 4 in that. So let's have a queue and insert 2 and 4 in it. And we will mark 2 and 4 wasted. Now from this queue, we will pick each vertex one by one and all the connected nodes of each vertex which are not wasted yet, we will insert those into this queue. So now we will pick 2 and we will remove it from queue and we'll add it to our sequence of traversed nodes. Now from 2 we can move to 1, 3 and 5. But as 1 is already wasted, so we will insert only 3 and 5 to this queue and we'll mark 3 and 5 as wasted. Now we will pick 4 and we'll remove it from queue and we'll add it to the sequence of traversed nodes. Now from 4 we can move to either 1 or 6. But as 1 is already wasted, so we will insert only 6 in this queue and we'll mark 6 as wasted. Now we will pick 3 and we'll remove it from queue and we'll add it to the sequence of traversed nodes. And from 3 we can move to 2 or 7. But 2 is already wasted, so we will insert only 7 in this queue and we'll mark 7 as wasted. Now we will pick 5. From 5 we can traverse to 2 or 6, but both are already wasted, so we will not insert any node in queue and we'll remove 5 from this queue and we'll add it to this sequence. Same we will do for 6 and 7. So in last sequence of traversed nodes will be this. Now let's understand the pseudocode. First we need a graph. Let's take graph as an adjacency list. Then we need number of vertices, so let's take number of vertices as v. And we need a starting node, so let's take starting node as 1. Now we have graph, number of vertices and starting node. Here now we need a visited array to keep the track of visited nodes, so let's take visited array. This can be of boolean or integer type. Here let's take it as a boolean type. Another we need a queue, as I already explained, so let's have a queue. So first we will insert our starting node in this queue and we'll mark it as visited. This starting node we will mark as visited. Now we will run a loop over this queue till this queue will not be empty. So let's have a while loop till queue not be empty. Now we will pick the nodes from this queue one by one. So let's pick the nodes one by one. Let's have a current node and pick from the queue. Now we will print this current node. We can store this current node in an array list or array as per the requirement. Now we will look for the neighbors of this current node. So we will run a for loop over the neighbors of this current node. And if neighbor is not visited, then we will add that neighbor to the queue. And we'll mark this neighbor as visited. That's it. So here we can see that it is a very simple algorithm, but it helps to solve many problems. Now let's implement the code. So here we have given the graph as adjacency list and number of vertices as v, and the starting node is 0th node. So here what we need, one boolean visited array, and the size of this visited array will be v. We need a queue, so let's take a queue. Now we will insert the first node into this queue, that is 0th node. So let's insert 0th node to this queue, and now we will mark this 0th node as visited. Now we will run a while loop till queue will not be empty. So let's run a while loop. Now we will pick each vertex one by one. Let's pick current node, queue.remove. As we need to return the answer as an array list, so we will take an array list. Let's take answer is equal to new array list. In pseudocode, we were printing this current node, but as now we need to return this array list, so we will insert this current node to this array list. So let's add this current node. Now we will look for the neighbors of this current node. For that, we will run a for loop. Here, if neighbor is not visited, then we will add that neighbor to this queue and we'll mark this neighbor as visited. That's it. Now we will return this answer. Let's compile this. This is fine. Now let's try to submit this. So this is a BFS traversal of graph. The time complexity of breadth first search is big O V plus E, as we are visiting each vertex once and each edge once. And the space complexity will be big O V, because here we are using this visited array and this queue. So that's it. Thanks.